Data coming back from orbit seemed to not make sense. The glow at the equator changed from place to place around the Earth in ways we didn't expect. We thought there was a problem with the camera and worked hard to correct the signal. But the signal was real, and the glow appeared to be affected by changes in the lower atmosphere. Now we are building the ICON mission, a satellite that will explore this region of the atmosphere where Earth's weather meets space weather.
I'm Thomas Immel, and I'm the principal investigator for the ICON mission. What that means is I am responsible for its success. It really takes a huge number of people working together to make a space science mission. And we have a team working on ICON that's been really great. That team is made up of a number of partners and partner institutions, and led by UC Berkeley, with oversight from NASA.
I'm Ellen Taylor. I'm the Project Systems Engineer of ICON. I oversee all the different technical aspects of the mission, including the launch vehicle, the payload, and the spacecraft bus. The team here at SSL is phenomenal. It's a great group of people to work with. Having an experienced and capable team is very important.
A lot of planning and design happens before we ever build a single component of the mission.
If anything breaks after the spacecraft launches, you can't fix it. So you have to do a lot of preparation, making sure that every aspect of the instrument or the mission is working as expected beforehand. We test the instruments by exposing them to all of the environmental conditions that they will experience. This includes the conditions during launch, when the spacecraft can experience significant vibrations. So we test the hardware by placing it on a special table that will shake it to simulate those vibrations. In orbit, the spacecraft will go in and out of the Earth's shadow and will experience big shifts in temperature. We simulate this by placing our hardware in a vacuum chamber and alternately baking and freezing it. ICON will launch on a Pegasus rocket. It is different from a lot of other launch vehicles because instead of launching from a pad, the Pegasus rocket containing the spacecraft is flown into the stratosphere aboard an airplane. The plane departs from an island in the South Pacific. Once it is at the right altitude and heading, it drops the rocket, which then ignites after a few seconds and carries the spacecraft into orbit from there.
Once the spacecraft is on orbit, we talk to it and command it from our Mission Operations Center here at the Space Sciences Laboratory at UC Berkeley. All the communications with the spacecraft will come from here, and all the data will be received here. Berkeley is very fortunate to have its own Mission Ops Center with a team with great NASA experience. And once we start receiving data, the science team will be on the case and be able to work to solve the mysteries of how the lower atmosphere is connected to the conditions in the upper atmosphere and space.
That is when the fun begins.